The entity relationship model, commonly known as the ER model, stands as a fundamental tool in the realm of database design. It provides a structured approach to conceptualizing and organizing data. This model is indispensable for anyone involved in developing robust and efficient database systems. The ER model offers both a visual and a conceptual framework for understanding data structures. It allows designers to represent complex information in a clear and intuitive manner. This dual approach aids in both the initial design phase and subsequent communication. Serving as a blueprint for database development, the ER model guides the entire construction process. It ensures that the final database system accurately reflects the real-world requirements it is intended to manage. This foundational step is critical for project success. A primary function of the ER model is to allow for a deep understanding of data relationships. It clarifies how different pieces of information connect and interact within a system. This insight is vital for designing an integrated and coherent database. Furthermore, the ER model enables effective communication of these data relationships among various stakeholders. Whether discussing with technical developers or non-technical business users, the model provides a common language. This shared understanding minimizes misinterpretations and ensures alignment. The ER model is employed prior to the actual construction of a database. It represents a crucial planning phase where the logical structure is defined. This upfront design work prevents costly errors and rework during implementation. By meticulously mapping out entities and their connections, the ER model lays the groundwork for a well-organized database. It ensures that the database schema is logically sound and capable of supporting all necessary operations. This preparatory step is a hallmark of professional database design. The entity relationship model is built upon three core components: entities, attributes, and relationships. Understanding each of these elements is essential for mastering ER diagramming and database design. Each component plays a distinct role in representing real-world data. Entities represent real-world objects or concepts that are distinct and identifiable. These can be anything about which an organization needs to store information. Entities form the basic building blocks of any ER diagram. The primary purpose of an entity is to store information about a specific subject. This information is then organized and managed within the database system. Entities serve as the primary containers for data. Examples of tangible entities include customers and products. These are physical items or individuals that exist in the real world and possess definable characteristics. Data about them is collected and stored. Abstract concepts can also be entities, such as orders or departments. While not physical, these concepts are crucial to business operations and require structured data storage. They represent significant logical units within a system. In the diagrammatic representation of an ER model, an entity is typically depicted as a rectangle. This simple geometric shape clearly distinguishes entities from other components. The name of the entity is placed inside the rectangle. Each entity represents a collection of similar items, not a single instance. For example, the customer entity represents all customers, not just one specific customer. This abstraction allows for efficient data modeling. Attributes are the characteristics or properties that describe an entity. They provide specific details about each instance of an entity. Attributes define the data points that will be stored for each entity. For instance, if we consider the customer entity, its attributes might include customer ID, name, address, and phone number. Each of these attributes describes a particular piece of information about a customer. They collectively define the customer's profile. In an ER diagram, an attribute is typically represented as an oval connected to its corresponding entity. The name of the attribute is written inside the oval. This visual link clearly associates attributes with their parent entities. A crucial attribute within any entity is the primary key. This special attribute plays a vital role in data management. Every entity must have a primary key to ensure data integrity. The primary key's function is to uniquely identify each instance of an entity. For example, customer ID would uniquely identify each individual customer in the customer entity. No two customers can have the same customer ID. Primary keys ensure that data can be retrieved, updated, and deleted accurately. They prevent duplicate records and maintain the consistency of the database. This uniqueness constraint is fundamental to relational database principles. Attributes can also be classified as simple or composite, single-valued or multi-valued, and stored or derived. Understanding these distinctions helps in designing a more precise and efficient database schema. Each attribute type serves a specific purpose in data representation. Relationships define the connections or associations between entities. They represent how different pieces of data are linked together within the real world. Relationships are crucial for showing how entities interact. These connections represent associations between different pieces of data. For example, a customer might be related to an order because a customer places an order. This association links two distinct entities. In an ER diagram, a relationship is typically represented as a diamond shape. This diamond connects the related entities with lines. The name of the relationship, often a verb, is placed inside the diamond. Relationships specify the type of connection that exists between entities. Common types include one-to-one, one-to-many, and many-to-many. These types describe the cardinality of the relationship. Cardinality indicates the number of instances of one entity that can be associated with the number of instances of another entity. For example, a one-to-many relationship means one instance of the first entity can be linked to multiple instances of the second. This defines the quantitative aspect of the connection. A one-to-one relationship means one instance of an entity is associated with exactly one instance of another entity. For example, a person might have a passport, where one person has one passport. This is a very specific type of association. A many-to-many relationship signifies that multiple instances of one entity can be associated with multiple instances of another entity. For example, students can enroll in courses, and a course can have many students. This type often requires an intermediary entity in a relational database. Understanding and correctly defining relationships is paramount for designing a functional database. Incorrect relationships can lead to data redundancy, inconsistencies, and difficulties in querying information. The accuracy of relationships directly impacts database integrity. The entity relationship model offers several significant benefits that make it an indispensable tool in database design. Its inherent characteristics contribute to its widespread adoption and effectiveness. These advantages streamline the development process and improve outcomes. One of the most prominent benefits is its visual nature, primarily through ER diagrams. These diagrams enhance understanding by providing a clear, graphical representation of the database structure. Complex data relationships become easily discernible. The ER model greatly facilitates the communication of database structure. Its standardized symbols and clear layout make it easy for designers to convey their ideas. This visual language bridges potential communication gaps. It is highly effective for both technical and non-technical stakeholders. Technical teams can use the diagrams for detailed implementation, while business users can understand the data flow and relationships without needing to know the underlying technical complexities. This universality is a key strength. Crucially, the ER model ensures that the database accurately reflects real-world requirements. By modeling entities and relationships as they exist in the business domain, the resulting database is highly relevant and functional. This alignment is vital for meeting user needs. The iterative nature of ER modeling allows for refinement and adaptation. As understanding of requirements deepens, the model can be adjusted and improved. This flexibility ensures the final design is robust and comprehensive. Furthermore, the ER model promotes a top-down design approach. It encourages designers to first understand the high-level data requirements before delving into specific implementation details. This structured methodology leads to more organized and scalable databases. The creation of an ER model is a systematic process involving several key steps. It typically begins with a thorough understanding of the data requirements and the business domain. This initial phase is critical for accurate modeling. The first step involves identifying entities within the system. This means pinpointing the significant objects or concepts about which data needs to be stored. Careful analysis of business processes helps in this identification. Once entities are identified, the next step is defining their attributes. For each entity, designers determine the specific characteristics or properties that need to be captured. This involves listing all relevant data points for each entity. Following attribute definition, the process moves to establishing relationships between entities. This involves identifying how different entities interact and depend on one another. The type and cardinality of each relationship are carefully determined. The process of ER model creation is often an iterative refinement process. Initial models are rarely perfect and require multiple rounds of review and adjustment. This iterative approach allows for continuous improvement. Adjustments are made based on feedback from stakeholders and a deeper understanding of data requirements. As new insights emerge or business rules change, the ER model is updated to reflect these modifications. This ensures the model remains accurate and relevant. This iterative cycle helps in uncovering hidden requirements and resolving ambiguities. It ensures that the final ER model is comprehensive and robust. The collaborative nature of this process is highly beneficial. The ER modeling process is not a one-time event but an ongoing activity throughout the database design lifecycle. It serves as a living document that evolves with the project. This adaptability is crucial for complex systems. The entity relationship model is a crucial stepping stone in the database design process. Its systematic approach ensures that databases are well-structured and efficient. Neglecting this phase can lead to significant problems down the line. It provides a clear representation of data structure. This clarity is invaluable for both designers and users to understand how information is organized. The visual nature of ER diagrams contributes significantly to this understanding. Furthermore, the ER model offers a concise representation of data structure. It distills complex data requirements into an easily digestible format. This conciseness aids in quick comprehension and effective communication. The use of the ER model facilitates efficient database development. By having a clear blueprint, developers can proceed with implementation with confidence and fewer ambiguities. This reduces development time and costs. It actively promotes data integrity within the database. By defining primary keys, relationships, and cardinality, the model ensures data consistency and accuracy. This prevents erroneous or duplicate entries. The ER model supports long-term database maintainability. A well-designed ER model makes it easier to understand, modify, and extend the database as business needs evolve. This reduces future maintenance overhead. Ultimately, employing the ER model leads to robust and well-organized databases. These databases are resilient to errors, perform efficiently, and are capable of handling complex queries. Their structure is inherently sound. Most importantly, the ER model ensures that databases effectively meet user and organizational needs. By accurately modeling real-world requirements, the resulting system is highly functional and valuable. This alignment with business objectives is the ultimate goal of database design. In conclusion, the entity relationship model is more than just a diagramming tool. It is a foundational methodology for conceptualizing, designing, and communicating database structures. Its principles are timeless and essential for anyone building data-driven systems. Mastering the ER model is a critical skill for aspiring database professionals.